Guys, I recently did 3 back-to-back live AI engineering workshop sessions. And what I did is I built an end-to-end RAG 2.0 and deployed it on AWS. I think that's a high value session, guys. So I combined everything together and giving to you in one video all 3 sessions now. So this will include everything from session 1 the RAG understanding, session 2 the improvement of the RAG, and session 3 the deployment part. Just go ahead and watch everything in one shot. You will love it. Are you able to see a blank note on the screen? Now you will be able to see the YouTube, but just write blank note visible, okay? So that I know blank note is visible. And please give a thumbs up to this video, guys, so that more people can get notification and they can join as well. Just write me BNV, blank not visible. That's it. Nothing else I want. Okay. So I'll start writing. I'm assuming it's visible. And welcome to this session, guys. And as I have been announcing about this session since some time, this session is all about AI engineering, and it will be a series of 3 live sessions. Okay. So I'm going to write here AI engineering workshop. This is not a tutorial, guys. This is a workshop. Okay. And what is the difference between a tutorial and a workshop, you know? So this is part 1. Okay. This is part 1. We are going to do part 2 and part 3 next 2 weekends. So what is why I have chosen this topic? Let me go to chat once and see. Yeah, note is visible. Okay, fine. So what we are going to do is we are going to first of all learn why we are trying to learn AI engineering. Okay. Why we are trying to learn AI engineering, that is the first part. Why AI engineering? Why not anything else? Second is, and important to understand, how generative AI project is built and deployed. Okay, how basically Gen AI project is, how Gen AI project is basically developed or deployed, whatever you call it. That is second part we will understand. And then we are going to do a end-to-end project right now. Okay, end-to-end project. And in doing this project, right, we are going to understand various components of Gen AI that you should know. Basically, various components of Gen AI, various components of LLM engineering that you should know. Now, let me hide this. So one part is why AI engineering we are learning, and how AI engineers is different from traditional data scientists or traditional programming. Can you tell me in comment, please, how AI engineers are different from traditional data scientists and traditional, basically, programmers, and why this is one of the most sought after skill in the market today? You call it AI engineering or you call it LLM engineering, whatever you call it, one of the most sought after skill in the market today. Why? What is your view? What is your view on this? So meanwhile you are thinking, I'll just start writing here. An AI engineer, an AI engineer, okay, wears 2 hats together. 2 hats together. Okay. And hat 1 is basically software engineering. Software engineering. And hat 2 is basically data scientists. Data scientist. Now, every time we discuss of AI engineers, we talk of scarcity in the market. And reason is very simple, guys. Somebody who has a software engineering background, very high possibility that that person might not understand what is the meaning of model evaluation, and somebody who has a data science background, that person, there is a good possibility that that person will not understand how to scale the application in production, how to do the proper configuration, how to do the monitoring, and how to build a scalable solution that can answer the business question, or what are the good practices for that. Okay, these are these are rare to find skill, not impossible to get, but rare to find skill. And hence, if you can command these two skills together, right, you are going to demand premium salary in the market, get premium salary in the market. Okay, so I'll not complicate this further, and we will simply move into. I'm not sure if you have watched my one last video that I had created. There was a video I created just 2 days back. Let me share my entire screen. Just give me a moment. I was sharing a window. I'll stop that and share entire screen. Okay. Okay. So I'm not sure if you have seen my video on RAG that I created like last week only, this Tuesday only. And this is building RAG from scratch. This is one video I created 5 days back. And in this video, I have explained you few things about how can you build a RAG. I mean, if you have not watched, go and watch this video, but this is not a prerequisite for today's course. But be it a RAG, be it a agent, or be it any generative AI application, right? What are the what are the important steps in, forget generative AI, forget RAG, forget agents. Just tell me, what are two critical uh, parts of any AI application? So I'm talking about machine learning, deep learning, anything. Okay. AI application, any AI application has two critical parts. What are these two critical parts? Can you think and let me know? What are two critical parts of any AI application, or two critical areas of any AI application? Can you let me know? Okay. So one part is, you can comment later, but I'll just continue. Maybe you are little lagging behind my timing basically. So you can comment there, but I'll just write here. One important part of any AI application is called training. Okay, training. And another important part of any AI application is inference. Correct? Training and inference. Inference means when you are using the application. Training means when you are building, preparing the application. One thing you need to understand here is, since the time generative AI has come, okay, this training has changed little bit. If you are an AI practitioner, or if you are into machine learning, or if you are into deep learning since some time, you will know that in the previous world, we used to do our own training, which means our data, our basically we will take one algorithm and we will train it from the scratch, and then we will get the model, and that model we will use in inference. But now, if we talk of generative AI application, this training landscape has changed, because you are not training your model from the scratch. What you are doing is, you are taking a frontier model, you are taking a already trained model, and doing something on top of that. What is that something? That something could be prompt engineering, that something could be multiple ways of writing prompt, developing a RAG, building an agentic AI system. But the landscape of this training has changed. That is what key point I'm trying to make here. Agree? Just, these are very, very conceptual things, okay? This is how things are changing in the world of AI now. So just drop a comment. Yes, you are agreeing with what I'm saying. Inference more or less remains same. The meaning of inference is, there is a model, trained model. I take the data and I will make the prediction or inference, whatever it is, and I'll do something in between. So in the previous world also, I might be doing some scaling, I might be doing some pre-processing. In today's world also, in Gen AI world also, I'll do something. So inference has not changed much, but training has changed a lot. I will take an example of RAG. and try to tell you how the inference will look like and how the training will look like. Sometimes this training we also call as offline process. Offline process. And sometimes this inference we can call as online process. Don't bother about continuous retraining, etc. for now. Just in generic sense, offline you do something and then this happens online. Okay. If you have watched my previous video of RAG here, this one, right? If you have not watched, later you can watch, but I will just explain you what is happening in a typical RAG application. In this video, I explained about a triangle. Okay. I said you, this is a RAG triangle. How the RAG triangle looks like. If I take RAG as an example, if this is a RAG triangle, okay, what will happen is at one end there is user, at this end there is knowledge base, and at this end there is large language model. Fine. User will come, fire a query. It will go and search for relevant context in knowledge base. Knowledge base will take user's query, give relevant context, pass it to the LLM. LLM will take everything, pass the response back to the user. This triangle can make you understand how RAG works typically. There are many things inside, obviously, but this is what is happening. At what time? Training time or inference time? At inference time. Okay, this is your inference pipeline, not the training pipeline. So, how your training pipeline is slightly different. Training pipeline in a typical RAG will look something like this. You will have some data. Please pay attention here. This is important. You will have some data and you will create some chunks. Chunks means parts of the data. Okay. From the chunks, you will create vectors because you want to store that in a knowledge base. And then you will put that in a DB. In our case, vector database. Data, chunks, vectors, and then you put it to the database. This is a training process, offline process. Don't confuse. Okay. And what you will do at the inference time, user will come, take a question. You will take it and you will generate embedding. Embedding means basically vectors in this case. Then what you will do is you will do the retrieval. Retrieval from where? Retrieval from knowledge source. So I'm talking about this line here. Okay. This line here. You are hitting the knowledge base. So you will do retrieve and then you will do prompting. Prompting means context preparation. And then you will do LLM part or generation part. And then you will do return. Return means return to the user. Okay. So this is your inference time flow or workflow. Why we are understanding these workflows in proper way is basically that is how you will arrange your code. Okay. That is how you will arrange your code. Without this, you don't know how to arrange your code. So you have to understand what is my online process, what is my offline process, and if I'm building a RAG project, then how do I arrange my scripts? Clear up to here? Everything is not online and everything is not offline. The way I will build my application will depend on these two flows if I'm talking of a RAG application. Fine. What I'm going to build now in front of you is a RAG application. And let me try to show you how that application will look like. This is the UI of the application. And the same application, what we will do is we will keep improving in our upcoming sessions. But today I'm building the first version of the application, which is baseline RAG end-to-end flow with all the important components, all the codes arranged in how it should be arranged in a production environment. So the name of the application is ML Research Assistant. What is the job of this? Ask a question about machine learning, deep learning. The assistant will search archive style papers and answer using retrieved context. If I go here, I think I have closed the application. So let me first go to cursor and start the application. So I'm not sure if you are using cursor for your work, but I am using cursor nowadays because this is AI assisted programming basically. Okay. So this is similar to Visual Studio Code, but since it is AI assisted, so I just uh, use this. Okay. I will give you this code or this entire project through GitHub. I have not uploaded in GitHub. I will upload it and give it to you. Maybe during the session only I'll give you. But once you have the code, what you need to do is just whatever steps I'm running, just see that you will be able to run the project. And then obviously we will discuss what these files are doing. Okay. Most important part to understand for an LLM engineer is how do you build your entire pipeline? And that is what I'm going to discuss in detail. But first, let's see the code. Okay. So when you have the code using git clone, I'll give you the git clone ID basically. You can do a git clone, have it in your local, and then go to this path here. Okay. ML research assistant, CD ML research assistant. Go there and then run UV sync. You know what is UV sync? UV sync is basically a faster and efficient way of managing your environments and basically something similar to .env, but it is very fast. Okay, so I'm using UV sync, and then the first thing I'm going to do is I'm going to do UV run -m scripts, and inside scripts I have a file called build index. Okay, let me run this. Okay, relative modules not supported. UV m scripts. Okay, scripts dot build index.py. Okay, what this will do is this will build my index. So this is the offline process that I'm trying to do. You remember I explained you two things here. One is called training or preparation. So training may not be a too proper word for this. You can just think of this as training or prep. Okay. So the script I'm running now, what it will do is it will do these four things. It will take the data, it will create the chunks, it will create the embeddings, and it will store in the Weaviate Cloud Vector database. Again, I will refer my last video. If you have not watched, you should watch, that will help you. Here I have explained you how to create a Weaviate Cloud account and load data from your local. Here I have explained you that, okay? But don't worry, I'll explain your code as well now. There is some error coming. No. Error while building. Try using script build index. A script build index. Okay. It is taking it as a module basically. Okay. So let me see if this runs. Okay. So what this part will do, this will take the data, create chunks, create vectors, and store that in a database. One command, it will do everything. And that is how it will, you create the pipelines. Okay. We will discuss the pipeline in detail. Don't get scared now. Okay. We will discuss the pipeline in detail. I just want to show you the application. If you see here, something is happening here. Okay. Collection paper chunk already exists. Collection is basically a higher level, you can say database in terms of vector DB where I'm storing my data. Loading dataset. So dataset is getting loaded using Hugging Face cache. So some data is there in my cache which it is using. First 5 papers it's taking from the ML research papers. Loading, it is generating 105 chunks. I'll tell you why 105 chunks only. And then embedding model. This model I'm using for embedding. And then indexing those chunks in a batch of 32 and then storing it. You see how many things are happening here? All these things are happening here. Data it's pulling. Okay. It is creating chunks. It is creating vectors and it is pushing in DB through one command. And that is how you build production grade applications. Okay. I will explain you this process. Don't worry. But first, let this happen. Meanwhile, what we will do is it will take some time because it is creating the index and loading, but not that much time also because I have just limited the number of papers to 5 for demo purpose. Are you enjoying the session so far, guys? Just tell me yes in the comment so that I know you are enjoying the session. First, we will see the application, the front end. We will get a feel of what it does, and then we will build it. Okay, step by step. So if you see here, my indexing is completed. Fine, my indexing is completed. And now what I'm going to do is I'm going to try to run the UI. UV run Python -m stream streamlit run app UI. Okay, so you will see that one UI is getting launched here. And in this UI, I'm gonna ask some questions. So let me close this unnecessary sessions. I was trying to figure out the Zoom problem, guys. It was a big problem. It was not working how I expected it to work. Then I need to do many things, so I was late for the session. Apologies for that. So you can see here, we can ask anything about basically 5 papers it has taken from the archive. So we can ask about that. So what is a variational inference? For example, if I ask what RAG should do, RAG should go and hit and it should take some chunks and it will tell. For example, now it's saying I'm not sure. Okay. And if I ask what is supernova, you will see that it is giving me answer. I'll tell you why this is happening. But first, you see that in the chunk, it is giving me a paper ID. It is giving me token ranges, which it is taking as a chunk. Okay. If you don't know what is a chunk, I'm going to tell you now. Don't worry, but it is retrieving chunk 1, chunk 2, chunk 3, okay, chunk 4 and chunk 5 because I have asked for 5 chunks to show here. In session 2, we will improve this retrieval, but for now, let's understand how this chunking is working and how these things are working. Okay. And for that, you need to understand what are the important components of any generative AI project. Very, very critical part of the session today. And think like this is your guidance for the interview. Okay. Important components of any Gen AI. In this case, I'm building a RAG, so it may be slightly RAG flavored. Okay. So let's see one by one, guys. First component of any data project will be data. Correct? First component of any data project will be data. And this data is nothing but your knowledge base. Knowledge base in our RAG application. In our RAG application, the knowledge base is nothing but ML research papers, which I am taking from Hugging Face. Okay. And if I go in my code base, right, I will explain you everything. Let's start one by one. If you go inside app and if you go inside data, then you will see something similar happening there. Let me explain you. If you go inside app, so this is app. Let me minimize so that it's easy for you. If you go inside app and if you go inside data, you will see load archive.py. Okay. It's a simple script to understand, but the key thing here is how do you create the entire pipeline? Okay. These are some of the pipeline, basically packages that I will need. And this is the main function, load archive paper. What it will do? It will load a subset of archive portion of scientific paper dataset, returns a list of dict with ID, title, abstract, and article. dsconf I am taking from config.dataset. Now this is how you build production grade applications. You write all your configuration things in config.py. Where is config.py? It is here. If you go here, you will see that there is a data config class. And in this data config class, I am saying Hugging Face name and Hugging Face config and max papers. If you want to fetch 50 papers, you make it 50. If you want to fetch 500 papers, you make it 500. But for demo purpose, I am fetching 5 papers only. HF name, HF config and max papers all will be used here. So you can see here HF name, HF config, load dataset, HF name, HF config. Which part we want? The training part. Max papers getting used here. For I in range of max papers, give me ID, title, abstract, articles, return papers. As simple as that. What we are doing here? We are fetching our data. That's it. Okay. And to fetch our data, we are taking the configuration from where? Config.py, this file. Okay. The first part here. All the configuration will be taken from config.py only. Are you with me till here? Any questions till here? I'll take a pause. Any questions till here? Nothing? Okay. So I'll move forward. So the first part is knowledge base app data. That part we just saw how we are doing in our code. You know what is the second part? The second part is since we are working with text data, basically generative AI application, so we will need to do indexing and vectorization or embedding, whatever you call it, vectorization. Okay. And this part is happening in our code where inside app, inside ingestion.py, basically, there will be a ingestion and there will be a ingestion folder, and inside ingestion folder, there will be chunking.py, and you will find some more things here like index.py, vb8.py. Okay, those things we will find. So let's see what is there inside ingestion. So indexing and vectorization both are happening inside ingestion. So go inside ingestion, and you will see that here chunking.py is there. What is happening in chunking.py? Again, we are taking from config, split text into tokens. This is basically normal thing. This is returning token. This chunk paper is important. Again, you see config is being taken from config.py. Okay. Tokens is getting created. Okay. And then chunk size token, it is taking again from config. Basically, you give the size of the token, chunk size, and then it is creating the tokens and chunks. And what it will do is it will just in a variable chunk, it will append all the chunks. Now, to make you simply understand what is a chunk, it's nothing but if I say here, hi, I am Aman, okay, a data scientist and AI educator. So let's say this is my complete document. A chunk is nothing but a subset of this. For example, this could be from here to here. This could be first chunk. From here to here, this could be a second chunk, and so on and so forth. So in our entire knowledge base, right? In our entire knowledge base, we will take the documents and we will create the chunks out of it. First chunk, second chunk, third chunk, and these chunks we will store. We will store where? We will store in the vector database. So what is happening here is basically those chunks are getting created. And then this function is getting called all chunks dot expand chunk paper. So we will get all chunks from this chunking. Once you have chunk, then what you are going to do? So see this flow here. You have data, you have chunks. Your next job is you create vectors and you store in vector DB, correct? So you come here, index VB8. What you are going to do, you are going to create a VB8 connection. Again, I have shown this in detail in this video. How do you create VB8 connection and how do you store in VB8 cloud data? But let's see one more time. Basically, VB8 is a cloud, VB8 is a vector DB. There you go and store that. For example, this is my VB8 cloud. Okay. And in this cloud, I have a collection norm with name paper chunk. See this carefully, guys. Paper chunk is my collection and this part is my one chunk. Okay. This part is the abstract of the paper and there will be a paper ID also. You see here paper ID is 14. So start token 0 to end token 300, paper ID 14. This is the chunk. Now you understand what is a chunk? You understand what is a chunk now, right? For this document, token number 0 to token number 300, we are calling it a chunk. Just like I gave you example here. Token number 0 to token number 300, one chunk. Okay. And then for the same 14 number document, for the same number 14 document, this is 29 number document. So this is paper ID 2. Okay. This is paper ID 3, paper ID 14. Okay. For the paper ID 14, start token 6750, 7050. That is stored here. So that is another chunk. So basically you are breaking your papers into chunks, and you are storing in this paper chunk vector database. How we are doing that? Chunk we have previously only created, okay? Now we are creating connection to VB8 client here. We are ensuring that schema exists, basically that collection, etc. And then these are the properties. So if you see paper ID, title, abstract, chunk text, start token, end token. See here, properties, chunk text, start token, end token, paper ID, title, and abstract. These are the properties which we are simply taking and pushing. Where from we are taking these properties? Again, we are taking this, as you can see here, data type.txt, and this will be coming from where? Configure property data type. So basically this is a function in your schema, and in this function we will push the data now. Index chunks, client, and if you see properties, so from the chunk we are taking and pushing it. Okay. From the chunk. Where from chunk is coming? From the previous basically part. Okay. From the previous chunking.py. So on the top they would have imported. We would have imported. So app.config, list, configuration, web sentence transformer. Somewhere that input will be there, or the reference to that module will be there. So chunking, or in the pipeline when we will call it, right, then we will refer when we run the entire process. Okay. So these two things are for your basically chunking and pushing data in VB8. As you can see, when I ran, the data got pushed into the VB8. Okay. So this part is from here to here is indexing, vectorization, app ingestion, chunking.py, index.py, VB8.py, and then build index I want to show you. Chunking.py, index.py, and there will be a inside scripts. If you remember, the first thing I ran is build index.py. So in build index, right, what we are doing is we are loading all our functions. So if you see, we are from this one, load archive paper, from chunking, chunk papers. From here, index, get VB8, everything basically from previous three scripts we are taking. Okay. Index, VB8, and chunking, whatever we are doing, we are taking here. And then we are just calling it one by one. In main function, get VB8 client, ensure schema first, then load archive paper, then chunk paper, then index chunk. Simple. This is how you build modular programming. And this ends your training part or preparation part basically. This ends your preparation part. So you finished all 4 steps. You imported data, you created chunks, you created vectors, and you pushed in DB. All those things you arranged strict how it should be done in a production setup, inside ingestion, inside data, and then inside scripts, you are calling that one by one. And then when you call the main function, everything gets inserted. If you remember, the first command I ran is build index.py, and then index was built. What is the meaning of index getting built? Nothing but the chunks are stored in vector database. This is your second part of a basically RAG project. Okay. What is the third part of a RAG project? Third part of a RAG project is retrieval. And this happens at what time? This happens in when you are using the RAG. Retrieval. Okay. And for this retrieval, what should happen? What should happen is your matching should happen. Okay. This is basically the RAG functionality. Matching should happen. And this matching is happening in our case, in our app basically. If you go inside app, if you go inside RAG, and if you go inside retriever.py, okay, let's see this file. I'll explain you now. Then you will know that how the retrieving is happening. Again, modular programming, easy to understand. Go inside RAG and go inside retriever.py. You will see that it's a very simple file of matching. Matching what? Matching vectors. So here you have some data stored, right? What we will do, we will simply take our data, create vectors and match with these vectors. That's it. So if you see here, I'm taking a sentence transformer for embedding. See here for embedding. Okay. What retrieve function is doing? It is encoding my query. Then it is doing near vector. Near vector means matching with the data in the RAG. And then whichever matches, right, that it's returning paper ID, title, abstract, chunk, text, token, and token score. So this file is again very simple to understand. You are having a embedder basically to create vectors. You will hit the Waviate because in Waviate your data is stored. And then through this function, right, through def retrieve, you are simply saying, give me the near vector. How many near vectors? 5. Give me the 5 near vectors. And that's it. You just take those chunks and return those chunks. So this is about retrieval part, retriever.py. Okay. I'm sure you would have never seen anyone explaining RAG like this. Okay. We are going step by step. We are understanding what is happening where. So question comes from the user, then embedding gets created, and then the retrieving happens. These 3 things is happening here. If you see again that file, we will start from user query, class retriever. Okay. Viviate this one. When we call this, like when we use this method, right? Self query, which is the user query. Okay. We will call with user query, and then we will go and search in the database. That is what is happening here. This is your retriever part. Now which part will come? Now which part will come in a traditional RAG or typical generative AI project? Now the part will come will be LLM part. Okay, LLM part. LLM part. And what this LLM part will do? It will simply take the context that you have done from the matching, and it will just try to prepare the response. So if you go inside again app, and if you go inside RAG, and if you go inside LLM client, you will see that whatever I explained you is happening here. Go here inside RAG, inside LLM client. From typing, these are the package config. Again, we need to import. So in config, as I showed you in the beginning, right? There are many things happening in there are many things in config. Everything is a configuration for these things. Okay. So for example, now I'm in LLM config. So I will need a model, right? So LLM provider, OpenAI, LLM model, GPT-4o mini. Temperature, I can change from here. Max token, I can change from here. So basically all the configuration I'm writing in config.py file here. And I will repeat it again. This is how you build production grade applications. You don't build production grade applications in Notepad. So all your LLM related things here. Then you go to LLM client. And what will happen here is very simple to understand. These are model specific parameters. We are taking OpenAI. We are taking key from the environment variable. And then we are hitting this URL api.openai.com, generating the answer with context. Where from context will come, two things will go, query and context. Context where from it will come? Context will come from previous step. Okay, the matching step. URL helpful system prompt, the answer based on provided context. If answer is not in the context, say you are not sure. User prompt, you give query, you give context. Very simple. And in the payload, you prepare the JSON and you just send it. You just hit basically OpenAI server and then you get the response. So I'm not using OpenAI.completion. I'm using a this method, and why I'm using it, you will know when we move to the next sessions. Okay. So here, what we will get in the output, we will get the response from the model. That's it. We will get the enhanced response from the model. So we are at which step now? We are at prompt step. Okay. And then LLM step. So we have seen that. Now the returning step. How the returning step will work. In your LLM, what will happen is all these things need to be called through a pipeline basically. So you saw that, right? When we are discussing this question embedding retrieve prompt LLM return, all these things will be called through a pipeline because it's a one shot run, right? So I'm going to write here pipeline. I'm going to write here pipeline. Okay. And what is the use of pipeline? As I told you, glue everything together. Glue everything. Okay. And where is your pipeline script? App rag pipeline.py. And what is there in the pipeline? What will be there, you think, in the pipeline? Nothing but all these steps stitched together. So question to embed to retrieve to prompt to LLM. That's it. Go to pipeline. You will see that it is importing LLM client and retriever. Both these things are important. In retriever, you are just retrieving. In LLM client, you are getting the response, right? So rag result, it will take rag pipeline, retriever, LLM client. It will simply say answer query. Okay. And in answer query, it will say just retriever retrieve LLM generate answer. That's it. Rag result will be query answer context. So this is what you are able to see in the front end. Query answer context. This is your query. This is your answer. And context we are not printing, but chunks we are printing. Okay. So this is your pipeline to glue basically these things together. Return, it will return. But now we need to run this pipeline also, right? So different ways to run this pipeline basically. And the way I'm taking here is UI way. So when I click on this button, right, search and answer, then pipeline runs and I'm able to get the response. So let me show you that as well. So the next part of my pipeline will be first of all, let's write here. Once the pipeline is done, then you will not do a manual run of the pipeline, or you will not do a user will not come to the command line, right? User will come to the UI. So in UI, we will call the pipeline, basically inference pipeline. And where is the script? The script is in pipeline.py. So no, pipeline.py is gluing everything. The script is in Streamlit. Okay. So this is basically Streamlit.py. Streamlit.py is inside my UI folder. So I will show you that UI. Streamlit app. This is the one. Okay. So if pipeline not in there, then start pipeline. Basically the first time render. This is your UI. What you will see in the UI. ML research assistant that you could see on the front end. The name, page title, basically this one, ML research assistant. This is title. You can see ask a question. This you can see. Then query. We are preparing the user query. We are stripping and we are using this to, you see here, pipeline dot, see here, pipeline dot answer query. Now, what was there in answer query? Do you remember? Come here and see. Pipeline dot answer query. And this takes query. This takes how many results you want. And that is exactly what is happening. Pipeline dot answer query. Query it is taking. Query is what? What you are giving in the input. Top K 5 means 5 things it will bring. And then it will give you the result. And now once the result comes, right, you want to show it to, you want to show the chunks, you want to show whatever you want to show, that is your choice. Okay. So here we are just basically taking the, see, retrieved chunks is printing, and then we are just taking the chunks and we are trying to print it. So if you see a CTX, right, for ICTX in result.context. So from the context, we will take that. Okay. So result is where you are getting the response. See here. Result is where you are getting the response. From this result, you can take the context, and that context also you can use it in whatever way you want to use it. For example, here chunk we are taking ctx.title, we are taking ctx.paper, we are taking ctx.start token, we are taking end token. So all these things that you are seeing here, basically, see here, paper ID, token range. Okay. So token range, start token, in token, score, and then chunk text. So everywhere you will see that. So 5 most matching chunks are here. So basically 5 is our result. Run a query to see retrieved chunks here, and this is main. So when you call the main, then basically all the things get called one by one. So this is the flow of your RAG pipeline. The above two are written in black color, and the reason of that is this is only training. This one and this one. And below 4 are written in other color. So inference. This one, this one, this one, this one. So this is our RAG now, and it is working fine. And if you ask something which it does not know, then it will say, I don't know. For example, these are my papers, right? So ask something which is not there in those papers. So for example, what is cricket? It should say, I don't know. I'm not sure. Okay. How we will know that? Which answers it will give? If I go to Viviet Cloud, I can see the chunks. Okay. And in the chunks, I can ask something relevant. Okay. So for example, go to any chunk text. What is Brock dataset? Let's ask. What is this one? Brock datasets, whatever it is. What is Brock dataset? It should give me something. Yeah, data acquired by part of something. The dataset consists of whatever it is, and it is checking from chunk 1. Chunk 1 is which paper? Paper number 23. So let's go here. Paper number 23. Paper number 32. Okay. Paper number 32. Why it is saying paper number? Did I take from other place? Paper number. One moment. Chunk 1, paper number 32, 0 to 300. Chunk 2, 32, 52, 52, 550. View collection details. I basically want to see where from it is fetching, because that is where our problem lies. Okay. Paper chunk. Large number of supernova. Let me ask supernova. Okay. Have been discovered and many more will be found. Once discovered, further study of possible astronomical knowledge of SN type. Current classification. Further study of a supernova and its type. Astronomical tool. So let me ask what is needed to study about supernova. Okay. Let me ask this. What is needed to study about supernova? To study supernova, several key components. Paper ID 14, token range 0 to 300. Paper ID 14, 0 to 300. Yeah, this is what I want to see. So it is taking from this chunk basically. Okay. And this is the first attempt to model the kinematics of CME launch and result. The model contains 14 free parameters. First, tell me about first attempt to model the kinematics. Let me ask. Tell me about first attempt to model the kinematics. Okay. The context provided does not specific information, therefore I'm not sure. So what is happening here is our chunking is working fine in some cases and chunking is not working fine in some other cases. Okay. The reason being the chunking strategy that we have used is not that uh, sufficient or high end or whatever you call it. So that there are different things we can do in RAG. This is a complete flow of RAG. Okay. But the thing is, how do you make it better? And that is what we are going to do in our upcoming sessions. What is missing here, first of all? What is missing here? Who can tell me? There is a question. RAG is used to avoid hallucination for sure, but above question about MCP. What is the data gen structure, data chunk overlap indexing? I am not getting your query. Can you write one more time, Prashant? Because I need to scroll a lot on the chat. So you can write one more time. That will be great. Okay. So this is our RAG and there are some problems with this RAG. Obviously it is working, but if I have to make it better, basically, then what I can do? The one part that I have not written here in this flow is called deployment. Okay. So let me write here deployment. This is the final piece of this flow that we are learning now. Okay. Deployment is another component that we should cover, and that also we will cover in upcoming session. But I'll just explain you what's missing in this current project. What is missing in current RAG? What is missing in current RAG? One, evaluation is not there. Okay. So how do you know that your model is good, not good? What is the performance? Are your chunks good or not good? Okay. That is evaluation. Second is chunking, chunking strategy. So normally we don't leave it to the model to decide how to chunk, and basically we take control of chunking. Okay. And that is what is important, and that is what we should do. Chunking strategy is critical, evaluation is critical, and we can also do different kinds of embedding. So for example, experiment with experiment with embedding. These are the things which you normally do or you must do in a production grade applications. Once you are happy with your model, once you are fine with your model, then you should basically put that in a version control or Git or somewhere. And then just to keep it simple, I'm writing code control, CI/CD, etc. This is one component. And the next component is deployment. Wherever you are deploying in cloud or you are deploying in some server, wherever you are deploying this. So what my plan is, next Sunday when we meet, right, we will cover these. After that, when we meet, we will cover these. So there are two more sessions, right? 7th of December, 7:30 p.m. IST, 7 December only, right? Let me double check. Next Sunday is 7 December, right? Whenever is the next Sunday, basically. Yeah, 7th and 14th. Okay. So 7 December when we meet, we will build first three. 14th when we meet, we will build bottom two. Now your questions, please. 14th December when we meet, same place we can meet. There are few things in the code which I will explain you. So RAG, what? So one by one, let's quickly see which part is doing what. Okay, let's quickly see. Virtual environment, all of you are aware of, I am assuming. But if you are not aware of, virtual environment is basically a place inside your installation of Python where you go and prepare an environment for one particular project to keep it separate from other environments and to keep it clean. Okay. There are two ways in which virtual environments can be used. One is in Python, you can create. What I have done in my case is I have done UV sync. As I was telling you in the beginning, UV sync is a faster and cleaner way of doing it. So if you remember in the beginning, I did UV sync. What this UV sync will do is it will go and read this file pyproject.toml. Okay. You see this file here, pyproject.toml. It will see this, it will see this, it will see this, and it will see the dependencies. And it will create a virtual environment for me. When I run UV sync, right, you will see it is telling me resolved 111 package, audited 89 package. So basically it is ensuring that my virtual environment is fine. And then using UV, I'm running all the commands. How do you normally run virtual environment? You normally create a virtual environment, then you activate it. Inside that you do installation. Inside that you run your code. Here I'm doing UV sync, which is taking care of my virtual environment using pyproject.toml, and I'm running using UV. Okay. Read me.md is about project. Requirement.txt is still there if somebody wants to use virtual environment. UV lock is there, which is created by UV. Don't worry about it. Okay. So this is about when you run UV sync, it will get created. Have this script is not needed. Show processed papers. I'll just delete it. So inside build index, we are just building everything and uploading. and rest of the things are inside app. Okay, inside app, inside data, you are loading the data. Inside ingestion, you are ingesting. Inside RAG, you are retrieving, and inside RAG only pipeline is also there, and inside UI, you are just seeing that. HF cache is Hugging Face cache, so don't worry about that. When you download from Hugging Face, it will get created. In .env, my personal codes are there. My personal API keys are there. What I will do is I will remove this. I will remove my own keys. Okay. And I will upload it to GitHub. So what I will do, I will go to my GitHub. I will go to my GitHub, Unfold Data Science Outside. I will create a new project here. In this project, I will upload all the files. But remember, in .env, I will remove my key. I will remove my Web8 URL. I'll remove my Web8 key model, everything. So you need to give that. How to give that, I have shown you in this video. In this video, I have shown you how to prepare your Web8 URL, Web8 key, etc. OpenAI key, most of you would already be knowing. So just, update.env is what I'm saying. I'll almost remove everything from .env and then upload it to GitHub and share the link with you. Okay. Share the link means you can come to Unfold Data Science and you'll be able to see that. Yeah, evaluation part is pending, that I told you, and hyperparameter tuning is basically whatever we are giving in config, what works good for well. Okay, good for us. That's what I mean to say. Whatever we are giving in config.py, right? In that config, what is working good for us is our parameters, right? So these parameters we can try with different parameters. Explain the superseding of cursor ID against Google anti-gravity. I'm going to create a detailed video on this topic. I will touch it there, okay? We need to do hyperparameter tuning. Yes, hyperparameter tuning we will do, and we will do using config and basically a combination of parameters. Okay, one more thing before we forget, guys. I am basically working with Super Data Science on launch of a Generative AI brand new course. Okay, so that course I'm just going to show you now. Not Generative AI, sorry, AI Engineering Bootcamp. Okay, so in AI Engineering Bootcamp with global certification is what we are working together on. And you can just come to this page. I'll give you the link and you can read about it. And if interested, you can pay the token and you can talk to me. Okay. With that in mind, if you have any doubts, guys, you can just post it below this video and I will see you in session 2. Meanwhile, take the code, run it. If you face any problems, we can discuss in the next session or in the comment. Don't worry about it. Just keep watching this video. Try running, try changing parameters, try working with prompts. Okay. And see if you are able to generate something more interesting, something more better. And check out this bootcamp page. You can talk to me one-on-one after paying 5,000 deposit, and then we can discuss about bootcamp. Okay. So this bootcamp is launching in January. You can talk to me about this one-on-one after paying the deposit. Just check it out. And I'll see you all in the next session. Thanks everyone for joining and take the code from GitHub. Okay. Thanks everyone for joining. Yeah, I think my voice is coming. I was checking in a different phone. Okay. So welcome to today's session, guys. And again, very interesting session we are going to have today. What we are going to do is we are going to extend our previous learning that we have learned in part 1. And what was the part 1? Again, if you have not watched, I encourage you to go to Unfold Data Science YouTube and watch the part 1. here, Unfold Data Science YouTube, and you can go to the live and you can watch the part 1. So what we are trying to do here is we are trying to do a 3-part AI engineering workshop. Okay. And in this workshop, it's not gonna be only talking or only study level things. It's gonna be um, production level things that we are talking. Okay. So this was the part 1 done a week back, and today we are doing the part 2. So before we do part 2, let's quickly revise what we did in part 1. Okay. So that all of you can understand what we are talking here. And if you like the part 1 or if you are liking this one, please give me a thumbs up, guys, and we are getting started. Just say thumbs up and we should get started. Okay. So first of all, what we did is in the last part 1, just a quick revision of what we built. Okay. So we built a fully functional RAG. Okay. RAG is standing for Retrieval Augmented Generation. Fully functional RAG is what we built in the last session. And what is the meaning of a fully functional RAG in general is basically a RAG will do few things. Okay. A RAG will take a user query. I'm talking about the inference time. I'm not talking about the training time. RAG will take a user query. Then what will happen as the next step? Then retrieving will happen. Let me put it here. It's little difficult to write. Then what will happen is retrieving will happen. First user query will come, then retrieving will come, and then what will happen is top k results, or in the language of RAG we call it top k chunks. Okay, so I will write here top k chunks will come. How many ever chunks you want, those many chunks will come, and then from these chunks context will get prepared and it will get sent to LLM, and from LLM user will get the response. So this is the flow of a typical RAG. Okay, traditional RAG basically. This is what you call as a RAG. Now, in last session, I had explained you in detail what is the difference between pre-training or preparation or data preparation or knowledge preparation, and what is the difference between inference. Okay, so here I'm talking about inference part. What I'm talking about? I'm talking about inference part here. What we are going to do today is we are going to build some production ready things in this RAG, or we are going to build basically a production quality RAG. And what happens in production quality RAG is it is not only this much, because we cannot depend on RAG giving us the right answer and everything working so nice in the first go only. So we are dependent on many other things. So what are these other things? We will just write it here. So this was your session 1. To the people who have joined now, we are doing a 3-part AI engineering workshop, and this is your session 1, and today is my session 2. So in session 2, as I told you, we are going to understand some very critical components of RAG. So the first part will again start from query. Okay, but after the query, when the retrieving happens, it will happen little differently. Okay, so it will not be a plain retrieving. So retrieving will happen first using something known as by encoder. Okay, and what this by encoder will do is I'll tell you in a moment what it will do. And then one new step will come here, and this is called re-ranking. In RAG, re-ranking is a very famous interview question. You can expect this in any generative AI interview. Okay, so re-ranking is what I'm going to show you now, how re-ranking works. And after that, what is going to happen is we are going to see top k. So top k based on the re-ranking, and then we are going to see very important part here, evaluation of RAG, how to evaluate RAG. Okay, and then we are going to understand how to send this to LLM and how to get the response. And in between we will learn one more thing, additional thing, which cannot be fit into the sequence, but that is a technical thing basically, that is known as, that terminology is known as chunking strategy. So that also we will see. But the new things we are going to see is retrieving using by-encoder, re-ranking using something known as cross-encoding. Okay, this is called cross-encoding. Very, very critical component. We are going to see evaluation of RAG. How to evaluate your RAG and how to tell that your RAG is good or not good, or how do you say to somebody that your RAG is doing what it should do. So we will see by-encoder, cross-encoder, retrieving, re-ranking. We will see evaluation, and we will also see chunking strategy. Okay. So first of all, let me launch the UI, and then what we will do is we will see the UI, and from the UI we will understand the theory, and from the theory I will take you to the code. Okay. So this is going to be the flow. So first of all, I will show you things in UI. From the UI, I will take you to the uh, theory basically, or understanding of what is that, and then I'm going to show you the code. Okay, so this way it will be very clear to you what is happening. Okay, what is happening. Now let me go to my cursor and try to launch the UI first. So this is my cursor, and I will launch a Streamlit app here. And when I launch the Streamlit app, right, you will see that few things are happening here. And I'm going to take a relevant query from the VB8 cloud. For example, this is a relevant query, how high radial velocity precision, because this is the data I have loaded. Now, these things I have covered in my part one, guys. So everything I will not go in much detail, but these I have covered in part one. How did I load the data? How did I build the basic RAG? Okay. So I'm just trying to take a basically meaningful query. Okay. So I'm taking this meaningful query and I'm putting this here. Okay. I'm putting this here and I'm saying search. Obviously, I have taken help of cursor to create the UI and many other pieces that I thought are useful. But I'm going to explain you everything, and it's very smart to learn using AI, guys, nowadays. Okay. First of all, when I search this on the left hand side, as you can see, this app will demonstrate you 5 metrics to measure retrieval quality, improve retrieval with cross encoders, and different ways to split documents. Okay, so this is our part 2, advanced RAG features. So what we are going to learn today, we are going to learn advanced RAG features. Okay, so what is happening here is, first of all, this is just a heading, don't worry about it. I'm asking radial velocity precision and I'm saying search. This is the answer I'm getting from my RAG. And first thing you will see is RAG evaluation metric. And in this evaluation metric, this is again an interview question, guys. When you go to interview, they'll ask you, how do you evaluate your RAG? Okay, I'm going to explain you all these things, don't worry. But I'm evaluating my RAG on 5 things: precision at K, recall at K, MRR, NDCG at K, and F1 at K. Currently, my score in all these is 100% for this particular answer or this particular fetch, basically. Okay. And here I have given some knowledge here to understand what are these metrics, but I'll explain you. It will be very easy. This is about your evaluation metric. Second part is re-ranking. Re-ranking is basically a concept where whatever default chunks you get, you re-rank that based on something else. Okay. So this is your before versus after re-ranking. So this is your re-ranked score for this particular query. Okay, so previous score and re-ranked score. Is this moved? Yes, this is moved. How re-ranking works, we are going to understand. Don't worry. This is your chunking info. So here we are taking a fixed size chunking, but this is a configurable parameter which we can configure in our application. Okay, and here I have again told you what these different parameters will do. Okay, and here are the retrieved chunks. So 5 chunks we are retrieving. Chunk 1, 2, 3, 4, and 5. Fine. What we are going to do now is we are going to one by one and first of all understand what is the meaning of evaluating a RAG and how do you do the RAG evaluation. So let me go to my note and I'll explain you what is RAG evaluation first. Okay, so I showed you UI. We will keep going back to the UI. But first, let's see what is the meaning of RAG evaluation. Okay, and by evaluation, if you have little understanding of machine learning or data science, you know what is evaluation basically. You have one data against which you will compare. Okay, so suppose your RAG gives the answer to it. There is a user query, and query is, for example, capital of India. Query is capital of India. And the answer that your RAG gives, is basically New Delhi. Okay, New Delhi. Now this answer should be evaluated against something, right? Then only we can say that um, how much accurate our RAG is. This answer needs to be evaluated, right? So for that we need something to evaluate against, right? Something to evaluate against. So what is that something? What we are going to do is we are going to take this user query itself and we are going to compare how much user query is there in the answer. So for this example, capital of India, New Delhi, it's not making much sense. But for example, if you take another query, for example, neural network, okay, neural network, and your answer says something like neural network is something, something, right? So here we can compare user query with the answer. So this can be done in two ways. One is either you compare query with the answer or you have some ground truth. You have some human prepared answer against which you can compare. Understand the difference, guys, okay? You have a query, okay? You have an answer, RAG answer. This RAG answer you can compare against either a human prepared answer, okay? Or for simplicity, you can also compare it against your user query, like how much is the coverage. So for example, neural network is my query. My answer says neural network something something. So what I can do is I can I can evaluate my RAG based on this as well. So this is about what do you compare and what against what you compare, right? Which of these two methods you think is better? Just comment me in the chat so that I will understand what is your understanding of this. Meanwhile, evaluation metric we need to understand. The first evaluation metric is precision, precision at K. Okay. This is the first evaluation metric in RAG. What is the meaning? Relevant, relevant items, relevant items in relevant items in top K. Okay. And meaning is, as I'm saying you in the interviews and all, they ask you these things. Okay. Of top K chunks, of top K chunks, how many are relevant? How many are relevant? So let's say the top K chunks, let's say in your top K chunks, three are relevant. Let's go to UI. Let's go to UI. How many chunks we are fetching here? So if you go to retrieved chunks, right? We are fetching 5 chunks. Okay. Out of these five chunks, how many of these chunks are relevant to this query that we have asked? Suppose 3, then the precision becomes 3 by 5, which is 60%. That is about your precision. So this is very similar to if you are understanding how machine learning precision works, right? Similarly, recall. So it is chunk by chunk, okay? It is not word by word. It is chunks relevance that we are trying to understand, not the words relevance. And chunks relevance also you can define. You can define, I'll show you in code how it is working, but you can define in multiple ways. For example, if you want to see how precision is done in the code, right? So go to evaluation, go to precision, precision at K. And what we are doing here, list of retrieved item IDs. set of relevant item IDs, number of top items to consider. So if you see here, we are starting from K, we are taking top K, and relevant retrieve is if that part is in K. So basically, if 5 things you are retrieving, right, and 3 are relevant, then it will become 3 by 5. The same thing that I explained you now. Okay, this is about your first way of evaluating RAG, that is precision. But we will understand 5 different ways of evaluation. First is precision, second is recall. Recall again, relevant items, relevant items, find, found in top K, and this is other way around. Okay. So this tells you, suppose there are 5 things in your, there are 5 chunks. Out of those 5 chunks, how many are relevant for you? This tells you different story. Suppose there are 7 relevant items. Then how many of these 7 is in 5? You understand, right? If you have some understanding of machine learning, you will know what is precision and recall, right? Meaning is how many relevant, how many relevant are you able to find? How many relevant are you able to find? Are you able to find? Suppose there are 10 relevant items in the entire knowledge base. Okay. But in your chunks, out of that 10, only 3 is present. So I'm taking 5 chunks here, right? In these 5, only 3 are present. So that will be 30%, 3 by 10. Okay. This is precision and recall. And again, if you want to see the code, you can see it here. Recall code. So top K we will take, and then relevant is basically length of relevant. So how many total relevants are there? And then based on that, relevant retrieved we will take. Okay. So we will here taking by relevant retrieved. So how many you are retrieving? Then comes your F1 score. Okay. Then comes your F1 score. So what is F1 score? F1 score, maybe you are having some idea already. To precision into recall, it is basically a balance of precision and recall. Okay. Balance of precision and recall. This is about your third evaluation metric. There is a fourth evaluation metric, very important one, and that is known as MRR. And what is the meaning of MRR is mean reciprocal index. And what it does is 1 by rank of first relevance. Understand the meaning of this, guys. Suppose in these 5 you are fetching 5 chunks, right? And most relevant chunk you fetch in position 1 only, which means if the most relevant chunk is found in position 1, that means your MRR is going to be 100%. 1 by 1 is equal to 100%. Suppose your most relevant chunk is going to be, first relevant chunk is going to be at rank 3. Okay. This is your most relevant chunk, but it is at rank 3. So what is going to happen? 1 by 3. That is your 33%. Okay. That is your 33% MRR. So mean reciprocal index. The meaning in plain language is how nicely you are able to fetch. Okay. How nicely you are able to fetch on top positions. If you are able to fetch the most relevant on top position, then 100%. If second position gives you, then it will be 1 by 2, like that. It will keep decreasing. Okay. This is the fourth thing. And if you want to see in the code MRR, mean reciprocal index, average reciprocal index of the first relevant item. Okay. So for rank item in enumerate retrieved, start at 1. So we are dividing by 1, right? For if item in relevant, what basically it is taking an average of all the mean, right? So average of all the chunks basically it is taking, but for one chunk that will be 1 by that number. Okay. And this number will be 0 to 1. If you are getting 1, that's very good. And then last but not the least, NDCG at K. And this is a normalized discounted NDCG at K, right? This is a kind of little advanced method. It is called normalized discounted cumulative gain at T. Means if list of retrieved items order by relevance you will take, set of relevant item IDs you will take, and number of top items to consider you will take. So what is happening? Don't worry about this formula. I'm going to tell you very simply what it is. And this is one of the criteria you will see everywhere RAG evaluation comes into picture. Okay. So this is called NDCG, and this stands for normalized discounted cumulative gain. The meaning of this is discounted gain normalized by ideal gain. So discounted gain normalized by ideal gain. So what it is telling you is basically when you are building, then when you are doing your re-ranking, right? So you remember I told about re-ranking. So these are my initial 5 chunks, okay? But after this re-ranking will also happen. And when re-ranking happens, then what may happen is I'll tell you just a moment what is re-ranking, okay? So then it will be easy to understand. What is re-ranking in RAG? Re-ranking in RAG. Suppose you run a user query. So this is a user query. And these are the 5 chunks. 1, 2, 3, 4, and 5. These are the 5 chunks. Now suppose user query is about diffusion models. Diffusion models. Okay. In chunk 1, there is a discussion of diffusion model. In chunk 2, there is a discussion of diffusion model. But in chunk 3, there is a discussion of neural networks. In chunk 4, there is a discussion of diffusion model. In chunk 5, there is a discussion of, let's say, autoencoders. Just an example. This is your original chunks that is being fetched. Okay. When the re-ranking happens, what will happen is relevant chunks will start moving up and swapping the position with non-relevant chunks. For example, first may still be diffusion models, second may still be diffusion models, but this diffusion model will swap position with this. Okay. And since this is autoencoder, so this will also kind of is a candidate for swapping position. So this is at 5, don't worry about this. But suppose these two are swapping position. So then third will be diffusion models and fourth will be neural networks. So if you see here, the position of 3 and 4 are swapped. Okay. Position of 3 and 4 are swapped. This is nothing but re-ranking in RAG. Now your top 3 is about diffusion models, which should happen actually. Fourth is relevant, but not directly relevant. So it has come here. Fifth is relevant, but not directly relevant. So it has come here. This process is called re-ranking process of chunks. So this is your first chunk, second chunk, third chunk, fourth chunk, fifth chunk. These are also your chunks, but positions are changed. This process is called re-ranking. How to do that, we will see now. But we were talking about this NDGC, right? So discounted gain normalized by ideal gain. And in another words, we can say here, for you to understand it better, quality of ranking with position discounting. Okay. So when the ranking is happening, forget about the position for a moment, but whatever the final ranking are you getting, how good is that ranking? Okay. And this is higher the better. Higher the better. So the evaluation metric that I have put in my new script called evaluation.py, if you see here. So first is here precision, second is here recall, third is here MRR, okay, fourth is here, and fifth is here F1 score. So as I was telling you, DCG logic is here, okay, you can see this. All these scores I'm going to compute in evaluate rank function. And in evaluate rank function, what we are going to do is, we are going to compare against what? If you remember, in the beginning, I told you there are two ways in which you can compare. This is your query, capital of India. This is your answer, New Delhi. This is your query, neural network. This is your answer, neural network is something. You can do two things. Take this query and compare against chunk. That is what we are doing here. The second way would be prepare a set of question answer pair. Okay. Are you with me? The second way would be prepare ground truth. What is ground truth? Ground truth is, for example, capital of India, capital of India, and the answer here should be capital of India is New Delhi. This is ground truth. Okay, capital of India is New Delhi. This is your ground truth. In production grade applications, especially in banking, finance, legal, these kind of domains, right? There will be a human who will be writing these ground truths. Okay. And you will have a very, very high quality ground truth. And when you evaluate your RAG, you will evaluate against these ground truths. I'm telling you this so that in the interview, you should not say that I have prepared my own ground truth. I mean, you can do it for demo purpose, learning purpose, but in real world, when you are evaluating your DAG, you need a RAG, you need a proper ground truth. Okay. Here in our example, what we are doing is, since this is also in some way or other uh, uh, a benchmark against which we can compare things. So why not compare against this only? That is what we are doing here. What we are doing, if you see, query lower, which means take the user query, convert into lowercase, take all the words, and from these words, right, see the relevance. How do you see the relevance? You see the relevance based on what is the matching score. Okay. So if you see here, consider relevant if score is in top 50%, roll distance is equal to better, or has significant key overlap. If one of these two conditions satisfy, then I will say that particular chunk is relevant. I am repeating it again. Suppose this is your query. Okay. This is your query. And for an example, I am saying this is your one of the chunk. Let's say this is your first chunk. What we are doing in our situation is we are comparing query with chunk. Okay. And or chunks. Okay. Chunk or chunks, because we are capturing 5 different evaluation metric, right? Compare query with chunks and then see where does the precision fall, where does the recall fall, where does the F1 fall, where does the MRR fall, and where does the NDCG fall. So for that, we need to call some chunks as relevant and some chunks as non-relevant, right? So how do you call that relevant and non-relevant? You call that relevant and non-relevant based on the matching. Okay. So here we are doing default to worst case if missing. We are taking the chunk text lower, and then we are taking the keyword overlap. You see here keyword overlap. Keyword overlap is we are seeing how many of these words are present in the answer. That is your keyword overlap. Okay. That is one criteria. If this is greater than 30%, then we say that it's a relevant chunk. Another criteria is score. So what is the score? Chunk dot get score. Okay. So this score is basically you can simply think as embedding score, matching score. Okay. Based on that matching score also we will say, and then we will get these 5 metric. So these are our 5 metric in the end. If you see in the front end, right, we are getting 5 metric: precision, recall, MRR, NDCG, and F1. Here everything is 100%. Okay, and whatever I told you is written here. Just you can read it. I'm highlighting. Okay, this is now a very good place for you to revise RAG evaluation. I explained you, I showed you the code, and here one line explanation of everything. So that's the reason I have put it here. These numbers will change. I will change it now and show you how it changes. Let's move to this is about evaluation. Okay. Now let's move to the re-ranking, and I will explain you how re-ranking is working in our scenario. So re-ranking is working in two steps. So there is a step 1 and there is a step 2. Okay. Step 1, what is happening is, suppose somebody asks, what is AI? What will happen in step 1 is, system will simply go to the entire knowledge base and find how many ever chunks you want. Suppose here we can configure the chunks. Okay, on the left hand side we can configure how many chunks we want, but suppose we want 5 chunks. Let's say an example 5 chunks. So in step 1 what will happen is, there will be a chunk 1, there will be a chunk 2, there will be a chunk 3, chunk 4, and chunk 5. Okay, so this will be matched, and using a technique called, what I explained you in the beginning, right? Here in the flow, I explained you by encoder. Okay, this retrieving will happen. So this you can simply think of matching. So your query will go and match and find the best matching sentences or best matching chunks. Okay, this is your first step. Now you have 5 best matching chunks. 5 best matching chunks. This is your step 1. Okay. And what will happen in step 2 is, among these 5, the sorting will happen. So if you remember, I gave you one example of sorting, right? So in step 2, it can be C1, C3, C5, C4, and C2. It is quite possible that after step 2, we will get this rank. Okay. And this will be re-ranking. Re-ranking. The technique used here is called cross encoder. And without going into much detail of what cross encoder is, just try to understand, if you run cross encoder on everything, on your entire knowledge base, right, your RAG will become very, very slow. They will ask you in interview, okay, why can't we run cross encoder on entire knowledge base? So here only on re-ranking you are using a cross encoder. Re-ranking uses a cross encoder model to reorder results by considering the query and document together. So it will take your query and it will take your document together. Document means now the chunks, limited chunks. This typically improves precision of top results. Top results means the 5 things that you have taken already. Why it helps? Initial retrieval uses by encoder, fast independent embeddings. Okay, so I told you here, right? Initial retriever. So you can write here, step 1 is nothing but initial retriever. Initial retriever. What it is using? It is using your fast and independent embeddings. Re-ranking uses cross encoder, slower but sees query plus document together. So this will take all documents and your query and do certain other kind of comparison. Cross encoders capture complex semantic relationship better. So this part you don't do on entire RAG. Basically, it's difficult to do. Okay. It's difficult to do this on entire rag. Not difficult, it's slower basically. It will take more time. So what you do is you first do a normal retriever and then using cross encoder, you just re-rank it. Okay. And once you re-rank, you will see that the position of your chunks are changed. Rank 1, 2, 3, 4, 5. Re-rank score 3.8 minus 3.3 minus 4.0 minus 4.4. It will keep on increasing now, negative side. Okay. So again, what we are doing here in re-ranking? We are doing two things. One is initial fetching we are doing, and then we are re-ranking it. What will happen if I remove enable re-ranking? Let's see. So from the left hand side, I am unchecking this. Okay, enable re-ranking, and I will run the same query again. Okay, I'm removing re-ranking and I am running the same query again. Now I expect evaluation metric to change a bit. Okay, it's not changing. Let me increase the chunks. Let me increase the chunks to 7. Search. I want to show you how the evaluation metrics are changing when you don't do re-ranking. So let me take some other keyword from the liquid gas phase transition is hot neuron in hot neuron. What is neutron basically? Let me ask what is hot neutron? Hot neutron. Okay, so I'm not running re-ranking now. I'm running the rag without re-ranking. See, precision has changed. Okay, and NDCG has also changed, and since precision has changed, so recall has also changed. So what it is saying basically is whatever 5 things or 7 things you are fetching in your retrieved chunks, everything is not relevant to your query. So my query is hot neutron, right? So my precision is low. Precision is low. The meaning is high precision means fewer irrelevant results. Little low means some results are irrelevant. Okay. So we can check that also in the chunk. Basically, if you go to chunk and if you search for that keyword, maybe in some chunk it will not be there. That's what my thought is. Yeah, I think in some chunks that word is not there. Maybe you can check it, but I think it's not there. So that is where your precision has come down. So why we discuss this is basically I wanted to show you if you don't do re-ranking, your rags performance is going to come down. Okay, so better to do re-ranking. Now if you enable re-ranking and do the search again, maybe with 7 chunks it might be little precision might be little weak, but let's see. Yeah, precision has improved. If you see, previously it was some 70s, right? Now it has come to 85. So re-ranking is helping. NDCZ is also changed. Okay, so which means that when we do re-ranking, our rag is improving. That is the key point here. Okay, so re-ranking we understood. So just you can think like first layer is happening on plain embedding and second layer is happening on contextual embedding or semantic meaning. Okay, that is what you can think for understanding purpose now. And where is the code? Re-ranker. Okay, in this re-ranker, as I explained you, there is a re-ranker class, and in this re-ranker class, what will happen is first of all it will take the original rank, and then it will use, if you see here, sentence transformer cross encoder. What is sentence transformer? Who can tell me in comment? What is the use of sentence transformer? Who can tell me in comment? Or cross encoder? No one? No one has ever used sentence transformer? Okay. So basically the same thing that I was telling you, right? First we are sorting on embedding, then we are sorting on contextual embedding. Basically semantic meaning we are capturing. And this is your original embedding, this is your re-ranked embedding, and this is your positional change that we are showing on the front end. Okay, so if you see, we are showing the re-ranked positional change original score. That is your re-ranking. Now the third thing of today's session is chunking info. What is chunking info? Chunking info is very simple. Chunking info is, suppose I have a big document in front of me. How do I want to create the chunks? Okay, so suppose you have the any Wikipedia page. Let's search a Wikipedia page. Wikipedia of generative AI. Okay, generative artificial intelligence. Suppose I want to store this in DB as a vector database. When you are creating chunks, then what you want to do? Do you want to create chunks like 300 words together, one chunk, and next 300 words together, another chunk? Is that what you want to do? Or you want to have an overlap between 300 words here and then start from word number 250 and go till 300. Then again have a 50 word overlap and then create new chunk. Is that what you want to do? Or you want to do a semantic meaning chunk? That also you can do, right? So these are different chunking strategy, and based on this your model performance will change, RAG performance. Okay. And this is normally in any machine, any generative AI project, your chunking strategy should be a part of your configuration. And I think I have also built like that. Go to config and see here chunking config. We are building a production grade application here. Okay. So in chunking config, you can give your chunk length, you can give your overlap length, and you can give fixed size or sentence based or semantic, whatever chunking strategy you want to take. What is the similarity and what is the difference? I told you now in the Wikipedia example. So if you ask me which works good in all scenarios, this question is cannot be answered because it depends. You need to try and see. Okay. But there are different chunking strategy that you should aware of. What are these? We are using now fixed size, and these are different chunking strategies. Fixed size, split text into fixed token windows, and some pros and cons. Sentence based chunking, split set sentence boundaries. Semantic chunking, group semantically similar content. Impact on RAG, better chunking, better context, more accurate retrieval. Semantic chunking often performs best for complex queries. How will you change here in the project? You will simply come here and in place of its size, you will say, sorry, you will say semantic. That's it. Okay. You will come here and you will say semantic, and your chunking strategy will change. And what may happen after changing this is you need to restore the data once in the vector DB basically. So you remember we ran build index in the first session. So you need to build index one more time and then you need to launch your app. Okay. That is about your chunking strategy. And then retrieved chunks are here. So basically now I'm retrieving 7 chunks. So all the chunks you can see here. So if you compare with our previous version, as I told you in the beginning, we have done, we are building an advanced RAG here. Okay. And when we talk of advanced RAG, then you need to be doing a smart retrieving, which we are doing by re-ranking and by encoder cross encoding. You need to have evaluation metric, which I explained you in detail, and you need to have a chunking strategy, better chunking strategy. Now there are many things with the RAG, but these are most important things. Okay, who can tell me what are other important concepts in RAG? Can you comment me? What are other important concepts in RAG? What are other important concepts of RAG? So there are more things like query expansion, query rewriting. Okay, but those are the things we can add, of course. But what we are going to do in the next session is we are going to take this application and deploy it. So in the first session, we built a fully functional RAG right from query to retrieving. We prepared our knowledge base also in VB8 Cloud. So some of you, if you are not familiar with VB8 Cloud, you can go and see my video on this one, build RAG from scratch. You will know how to build a VB8 Cloud RAG, enabled RAG. Okay. And that VB8, we have, this is a vector DB basically. So these are our data here on the vector DB. We have put our data. And we have built a fully functional RAG in the part one of our demo. Okay. Today we improved that RAG and we saw how we can incorporate re-ranking, evaluation, and chunking strategies in our RAG. So this RAG is fully functional and better quality RAG now. Okay. Now what we will do as a next step is we will take this RAG and deploy it to the production. That I'm going to cover in the next part. Any questions, guys? Feel free to shoot. I'll take a pause here. Any question? And one more thing I want to let you know that I am launching a AI engineering bootcamp with Super Data Science. This is starting in the month of January. And as you know, Super Data Science is a global name in uh, data science and AI trainings. So you can check this out. I'll drop you the link. This is Super Data Science community where there are 6,000, 7,000 people, and Super Data Science is a very well-known name in the world of AI and machine learning, mentoring, boot camping, training, etc. You can check out this. The global bootcamp price is $6,000, but India price is 49,000 only, and this is launch price. If you want to know more about this, you can just pay 5,000 deposit and talk one to one with me. Okay. So I just thought of letting you know. You can simply go to this, read about it, and let me know. Okay. Hello from South Korea. Hi. Hope you are doing good. Missed last session. Same ID used today. Yeah, I'm using cursor, I'm using anti-gravity, and I'm using VS Visual Code also nowadays. So I'm using many things. Best link to learn SAS and R. I will say you can learn any of these things in ChatGPT or any tool. So let me know, guys. Did you like this session? How did you like it? Let me know in comments so that we can do the third session with more energy. I think we have covered a lot of good things in today's session. And we have seen a fully functional, very good quality rack. So what I will do is I will first of all delete this HF cache from my system and I will push the entire code in GitLab and I will give you the uh, link in the comment of this video. When this video gets released, right, in the comment of this, I will give you the link. Okay. Okay, guys. So if you have any queries on the video, you can write. And I will see you in the next weekend on 14th. Fine. With the third part, the deployment part of this same RAG. I will see you with that. Anti-gravity, I have done a full session on YouTube, but if you want, I can do a dedicated session on anti-gravity as well. I mean, one session is already there. If you see here, right, in videos, anti-gravity is there. 30-minute video. It's a very complete video. You can watch that, okay? And then you should also subscribe to my shorts channel, guys. You are not subscribing. So you can go to AI Bits by Aman and subscribe to this if you have not done yet. Here I keep not AI notes, AI Bits. Here I keep sharing short content. Okay. So if you want to learn short contents, basically in the short way, you can subscribe to this channel today, AI Bits by Aman. Okay, just do that. If you see, I'm sharing a lot of interesting things here. 90% of AI startups will die by 2026. The AI revolution is here, dark side of AI agents. So I'm sharing a lot of nice things here for you. Just go ahead and subscribe to this AI Bits by Aman. Okay. Can you give me a message, guys? I'm visible and I'm audible to you. Just give me a message. I'm visible and audible to you. Okay. Can I get started, guys? If you give confirmation, I can get started. Today is gonna be very interesting session. Give me a confirmation if I'm audible and visible, then I can get started. Okay, I am visible and audio to you. Okay, I think you're saying I'm visible and audible both. Okay, fine, cool. Thanks for joining, guys. And today is going to be very interesting session, the last session of our AI engineering series, basically. And if you remember what we have done in first two sessions is, in first session we built a RAG, the basic RAG. In sessions two, what we did is we built a chunking, we built a re-ranking, and we built some more things on our RAG. So some of you who has not watched those two, you can simply go to Unfold Data Science, you can go to live, and you can watch these two. Okay, so what we have done here at a very high level, we have done built a basic RAG here where we understood what RAG is, how it works, etc. In the second week, what we did is we added re-ranking, we added evaluation, we added chunking strategies, and some more things on this RAG. So this is about these two. And today we are in part 3. What we will be doing is we will be taking our RAG to AWS. So we will be doing end-to-end deployment. Okay, sounds good. Give me a thumbs up if you are liking this, guys, and if you want to do the deployment with me. Give me a thumbs up. And first thing you have to do is you have to go to GitHub. If you want to do with me, go to GitHub and just clone this in your local machine. So go to github.com, unfold data science, ML research assistant, clone this in your local machine. Clone means you can also download it or do a git clone. Whatever you want to do, you can do it. Okay. Download it, open in your code editor, whatever. Or if you want to do a git clone, obviously you can do it. Whatever you want to do, whatever better you can do, and keep this code with you. I'm going to explain you what I'm going to do now. Okay, listen to this very carefully, and then we will be going into the deployment part. So what is happening now is I'm having an IDE in my machine cursor. Okay, it can be a Visual Studio, it could be any other IDE, and I'm putting all my codes, all my scripts here. So I will show you that. So for example, if I go to cursor in my machine here, I have all the codes and everything. What I have done is I have pushed everything to Git. So the Git which you are seeing here, I have pushed everything to Git for you to download. And what I'm going to do now is in front of you, I'm going to deploy everything to AWS. And how that will happen at a very high level, this is my local machine. So cursor, my local machine. From this cursor or from my local machine, from my local hard drive, what I will do is I will push this code to AWS EC2. Now, some of you who is not aware of what is EC2 in AWS, do you know what is EC2 in AWS? Anyone knows what is EC2? Okay, no problem if you don't know. EC2 you can think of as a server on cloud. Okay, So I will write here server on cloud. Okay. And what we will do is we will push all our code to Amazon Web Services server on the cloud. And what we will do is we will do all the setup here. So we will do everything from scratch. Okay. We will do all the setup. We will do all the package installation, whatever you call it, that will come in the setup only. We will build the index. If you remember in the first lecture and second lecture, the first thing we should do is we should build the index. Then only we can build a RAG, right? So we will build the index, and that then what we are going to do, we are going to run our app. And this time when we run our app, right, what will happen is this app will be accessible from the public internet. So for example, if I go here, if I go to let's say any website, I will give the number. For example, I can give 30, 120, 340, 23. This will be my IP address of my server where my app is hosted. And then you can also access from your, it should be dot dot, not colon colon. Colon is for port number basically. So imagine first four things as dot dot, okay? And then on this address, my app will be accessible to the open internet. That is what the purpose. Okay, sounds good? Give me a thumbs up if it sounds good. Excited to do this? Say excited in the chat, guys. Don't be so dull. We are learning here something very, very important. Okay. So if you want to watch or you want to do with me, both your choice. But I have put all the instructions in deployment.md file here. So you have to go and open this deployment.md file. And here everything is there. AWS EC2 deployment guide. This is complete step-by-step guide to deploy ML Research Assistant RAG application on EC2. Some prerequisites, since we are doing on AWS, obviously you will need a AWS account. You will need a Windows machine with PowerShell or Git Bash. This is normally you might be having. You will need a VB8 Cloud URL and API key, obviously. OpenAI API key, obviously. And SCP client. This is very similar to what this is, so don't worry about it. I'll follow all the instructions from here in front of you. There is a lot of instructions, but it's going to be very, very interesting. I'll keep explaining you what I'm doing. First of all, we should go and search for AWS login. Okay, and I want to go to AWS Management Console. Here I will sign in. And since I'm already logged in, so it is taking me to my login. As you can see, UFDS is written here. So UFDS is my account. UFDS is written here. I will follow all the instructions from this page, guys. Go to AWS console, navigate to EC2 service. So I will go either you can write here EC2 or it's coming here suggestion. I'll click on this. Okay. And then I'm going to launch a new instance. Launch an instance means launch a new server. Then I can name this server anything I want. For example, I will say Aman L, not LLM, AI engineering. Okay, so let's say this is the name of my server. Then here, click launch instance, configure name, any name you want to give. Select Ubuntu service 22.04 architecture 64-bit. Come here, select Ubuntu. Okay, and here you can see Ubuntu server 24.04. You can go with 64-bit, there is no problem. Instance type, you can go with T2 macro, there is no problem. This is one important thing, okay? Pay attention here. You will need a key pair when you want to log into this server, okay? What you need? You need a key pair when you want to log into this server. So I will go and say create new key pair, okay? And I will name it something. For example, Aman AI ENG. This is the name of my key pair. I'm downloading a PEM file, .pem file, okay? And I will say create key pair. Key pair is downloaded in my downloads now. So if you can see in my downloads folder, there is this Aman AI eng.pem. This will be used to log into the server. So this is important, okay? Now, if you go to instructions, right? So we have selected T2 macro. You can go for T3 medium or T3 large, depending on if it's a production. But now I'm showing you the from application point of view, right? Keep here. I told you just download it and keep it somewhere safe. Then you go to the network. So here you will be a network setting will be there. And here you can go to create security groups. Okay. And let it be like this only. And what you can do is select existing security group. No, create security group. Okay. Anywhere this is fine. And let me go to my instruction. Click security group, click edit. Okay. So I need to edit basically create security group. There will be an edit. Okay. And here what we need to do is let it be like this and we will do a add security group role. In this role, what we will do is if you see here, right, security group allow SSH traffic from IP 40/0. Okay, add security group rule custom TCP 8501 and this number. So this is very important, guys. Otherwise, your app will not launch. So this will be custom. Okay, here you can give this. Fine. In the description, you can give STREAMLIT app. This is just for your understanding of what it is doing. And in the port, right, you have to give 8501. Okay. And move ahead. So in my instruction here, description Streamlit app port 8501 custom TCP. So custom TCP protocol port range source description. Okay, fine. Now what we will do, we will come here and increase our configuration storage to 20 GB because 8 GB is not enough. 8 GB is not enough. So let's take 20 GB. We are defining our server here. Okay. And then we will say launch instance. So keep everything as it is. And here on the right hand side, you will see a button launch instance. What is the meaning of launching instance? The meaning of launching instance is very simple. We are renting a server on AWS. So on AWS, Amazon Web Services, we are renting a server. You can rent processing, you can rent storage, you can rent servers on cloud. So right now I am renting a server. If you have doubts on how these things work, I highly encourage you go to Unfold Data Science and go to playlists. And this is one of the most watched playlist on Unfold Data Science. AWS for data science. As you can see, there are 16 videos. Watch these videos. Your life will be very easy in understanding how AWS works. Okay. What I'm going to do now is my server is launched, successfully initiated launch of the instance. If you go to instances and if you go to something like I want to basically put here a launch instance I have done. I want to launch put here a elastic IP. This is optional, but if you do this, what will happen is your server will not always change the IP addresses. Okay. So in EC2, go to console on elastic IPs. So on the left hand side, I will go here, elastic IPs. Okay. And I will say allocate elastic IPs. I will say allocate. So what will happen is it will allocate an elastic IP to that. So then the IP address will not change every time you shut down the machine. Basically, this is optional, but again, if you want, you can do it. Now go to EC2, click on EC2, go to instance. You will see that my instance name is Aman AI Engineering, this one, third one. Okay. So let me click on this instance. And since I'm clicking on that instance, so I will show you something. If you see here, the previous two instances are already running and this is initializing. So our our instance is now initializing. It's not live yet. Okay, it's not live yet. It is initializing. So you have to wait for some time. Not too much of time, just 1-2 minutes. It's still initializing. So if you come here, right? If you click on that instance name, if you click on this instance ID, there is something known as public IPv4 address. And this is a very important address that you need to copy and keep it somewhere safe. So for example, what I will do is I want to put it in Notepad++ basically. What I will do is I will put it somewhere. Let me open a new file. I'll put this here. Okay. This is my public IPv4 address for the new instance. Fine. And then whatever you have done with this instance will show here. For example, what is the security you have put, what is the storage you have put, all those information, it will show here. So let it be. These are not pretty important for our deployment now. But what is important for us is if the instance is running and ready to use. So instance is running, and as you can see status 2x2 check passed, which means my instance is ready to use now. Okay. How will you log into this instance from your local machine? That is one important thing. For that, what I will do is I will open something known as PowerShell. You can do it in multiple ways. You can do it from AWS CLI. You can do it from different ways, but I'm using PowerShell. Okay. And the command to log into that instance will be you remember this is the IP address of the instance. So from your local machine, you have to do an SSH. So what I will do is I will take this and I will put it here. If you see this entire command, guys, SSH-I, C users among our downloads, and here the name of the file should be the name what is there for my file. You remember we downloaded one file in the beginning. Downloads. What is name of our file? Aman-AI-eng. Aman-AI-eng. Okay. This becomes our script to log into the command to log into that server. But before that, one final thing you need to check is go here and ensure that Aman R has permission to read and write this file. So go to properties, go to security, click on advanced, and first thing you need to do is disable inheritance. Okay. Convert inherited permission into explicit permission on this object. Remove all inherited permission. Okay. So I will say apply and okay. This is one thing you need to do. Second thing you need to do is edit. This is just a basic safety. I will say Aman R, and to this Aman R, I will give all the permission. So read permission is there, but I will give full control. Okay. Sometimes this key is not accessible, then that becomes a problem. So Aman AIENG.pem. Now, if you want to, whatever I'm doing, right, everything is there in the Git, guys. Don't worry. Come here, locate your key file, navigate to this folder. I'll do it now, don't worry. And then whatever I did now, it is telling you go to property, click advanced, uncheck, include inheritable permission. When prompted, remove all. This is what I did. Okay. Click OK. Now I'm ready to log into my remote server. So what I will do is I will copy this command and I'll come here and I will paste. So first time it will ask you, do you want to go ahead? And then if you can see here, right? Let me increase the size for you. Edit properties 24. Okay. Let me increase a little bit more. Properties 28. So I'm inside Ubuntu IP 172.31.26.176. This is basically if you go here to the instance, right? You will think that I am logging in here, then why this address is showing? But this is a private IPv4 address that will show, don't worry about it. I am logged into this server. Okay, I'm logged into this server. Now what I need to do is I need to transfer all my codes to AWS. How I will do that? The very first thing I need to do is go back to here, SSH we have done. If it doesn't work, use the full path. Remember, replace this with your key, replace this with your IP. Okay, some troubleshooting if it does not work. Now I will go ahead and set up the application. So when I want to transfer my file from local to there, right? One thing we need to keep in mind is my file also has virtual environment, okay, which is very big in size. Then sometimes it can have a Hugging Face cache, which is very big in size. So these things I don't want to transfer. I want to transfer only code. I don't want to transfer big files. So for that, what I have done is I have written a script here. Okay. And the first thing we will do is we will simply run the script called deploy copy to ec2.ps1. So if you see here, right, copy to ec2.ps1 will exclude these files. I don't want to transfer these files basically. Okay. I want to transfer only code. So don't worry about this shell script. This is basically transferring your files. That's it. You can do it using SCP also, but this is an easier way. Okay. So if you go to this one, right, run the SCP script, replace your name. The script will execute large directories, exclude, copy only file, transfer to EC2, and then env file is not copied as it is in git ignore. So I will create it later. Fine. Option B is manually. Manually using SCP, you can do all these things. But why do you want to do manually, right? Let's do it through the code. Okay. And what is the code? The code is this one. And let me copy this and tell you how you should edit this. So what I will do is I will paste it here. And what is my key path, guys? My key path is this. So let me copy here. What is my instance IP? My instance IP is this. So let me copy here. Okay. And then copy this entire command. Go to your wherever your project is. In my case, it's in Cursor. In your case, it could be in Visual Studio Code or anywhere. Just run this. Okay. Once you run this, you will see that after some time, the transferring messages will start coming. Okay. Which means file is getting transferred from local to AWS EC2. If you see copying project to EC2, excluding large files, and then it is filtering files. Okay. So what should happen is file should get transferred. File should get transferred. Okay. So it is basically creating connection and then it will start putting the files, but it should be very fast once it creates connection. This is the first time to that server, right? So we will come back to this, but I want to show you where the files will come. If you come to my EC2, right, and go to home Ubuntu, this is where my files would come. Currently, nothing should be here. Nothing is here, right? Nothing is here. These are hidden files. Just ignore that. But nothing is here. So what I'm expecting is all the files from my local should come to this location. Okay. And if we face any issues in this, we will see how to fix that. That is about deployment, right? We need to see where the issues are and then we need to fix it. But I'm hoping files will transfer. Let's see. Okay. As you can see, files have started transferring. So deployment.md, readmd, config, load archive, chunking, embedding, index VB8, evaluation, LLM client. So all my project files except big files have started getting transferred and it will finish in like few seconds now. Okay. So if you come here, right, you will see ls minus lrt, if I do one more time, you will see that a new folder has been created, ML Research Assistant. And if I go inside this folder, right, you will see that files are present. Okay. So these are my files, app, deploy. These are my files. Okay. So in my project, right, you will see app, then deploy, then scripts. These are my folders. So app, deploy, scripts are my folders. Then pyproject.toml, requirement.txt, uv.log. All these things are here. pyproject.to, deployment.md. All these things are here. Okay. So everything is now where? Now in AWS. So whatever I did now, all the instructions are written here. Open PowerShell, run the SCP if you want to do it later, of course. If that does not work, go to option B and you can transfer files one after another. I verified that file is already there. So I have verified. Now what we need to do is we need to run a, actually I'm inside ML Research Assistant. So I need no need to change my directory. But what I need to do is I need to run setup ec2.sh. Now somebody will ask, what is this script doing? This script is doing nothing, guys. This script is simply setting up the Python. Okay, so if you see here, this is again a shell script. What it will do is it will simply sudo apt get update y. So let me run that script. This will take some time to run actually. So basically you can think of setting up your environment in the remote machine. Remote machine means AWS. Okay. So you can see some commands are running here. What are these commands? Let's see this file. First of all, it will update your server. Okay. It will install Python and pip. Okay. Then it will try to create a virtual environment. If virtual environment is there, it will not there, it will create, and it will upgrade the pip. And most important, line number 61, it will install all packages from requirements.txt. If you remember, we have put all our needed package in requirement.txt. So what my setup script will do, it will install those packages. And this is very important for environment setup, right? So it will execute this code. And then these are just some indicators, but we will set it up later. Okay. And this is your commented code. Don't worry about that. Environment created. And inside this, you can do a source and you can run your Python script. But first, let it happen. Okay. So if you can see, it is doing it. And it will take some 2-3 minutes maybe, because for the first time on a new server, we are setting up the things. So as you can see, packages are getting installed. This is a brand new server that we created together. Like I created in front of you now, right? So it will take some time for the first time, but this is good to see. We are doing things from the scratch, guys. I'm not showing you anything that is pre-built, because if I face any issues, I want to show you how to fix that as well. That is the whole idea here. So let it run. Meanwhile, what we will do is I will just give you a quick view of how we have been building our things, right? So um, in our RAG, there is basically we are building a RAG 2.0. In this RAG 2.0, the important thing is building the knowledge source, right? And these knowledge sources are nothing but research papers, which we are taking from archive website and we are putting it into VB8 cloud, right? So what we will do is, after our environment is set up, these are the things that will happen. Okay. Read papers, read papers from website. These are the things that will happen when we do build index. Okay. Create chunks, create chunks and load in VB8 and make knowledge source ready to be used by RAG. To be used by RAG. So these three things we need to do. And these three things will happen through a script called build index.py. Build index.py. If you come to build index.py in the local, I will just show you. Go to scripts, go to build index.py. You will see that build the initial VB8 index from archive dataset, and we are indexing, and then we are creating a VB8 connection, and then we are putting data inside. Okay, we are putting data inside that chunk. Let's see where our deployment has reached, the installation. So installation is happening, guys. Don't worry if it is taking some time. If, as I said, right, if it fails or if there is some problem, right, we should be live resolving it. And one more thing I want to tell you. So these three things, right, read paper, create chunks, will happen through build index.py. But build index will need two things. One is your VB8 URL and VB8 key that we discussed in part 2 of this LLM engineering series, AI engineering series, and your OpenAI key. So if you see this dot environment file, right, I have intentionally not put anything here. Put value here, OpenAI, GPT-4o mini. If you go to GitHub, for example, okay, if you go to GitHub, you will see a .env. Here, I am saying .env example. OpenAI key, put value here. Here you should put your key. LLM provider, you should put. LLM model, you should put. You should put your configuration, you should put your configuration. Now don't ask me how to put this configuration. I have explained you many times. And if you want a revision, just go to build RAG from scratch this video. I have shown you everything, how to get a VB8 URL key, everything. You can get it from here. Okay. And I have used it in all my videos also till now in live. So all in all, you need to put your details here. If you remember, when I copied files to the remote server, I ignored .env, and that was intentional. Why that was intentional is I don't want to share my key with you. So I have just put a template here, and in the remote server, I will create it and put the keys manually. Okay, I will stop sharing for a few minutes, but when I stop sharing, I will create this file in remote. Okay, so what I'm trying to tell you is I will create a file in the server called .env, and I will put my keys, and that time I will stop screen sharing. Fine. So let me see what happens to my installation. Press enter after key. .env template created. Okay, fine. Okay, so I think the setup is completed, but I have not yet put my key. I mean, if I do a ls minus LART, you won't see a .env file here. Okay, but .env file should be here. In here, GitHub, you will see a .env, but here you don't see a .env. I will create a .env now, and I will put these values. Okay, so let me copy this. Let me copy up to from here to here. I will say nano. Nano is a editor in Ubuntu basically. .env. Okay, I'm creating a new file here. Okay, the file is created. Okay, I think that script has created this file, but why in the when I did a ls minus LART, why it was not? I'm interested to see. .env file when I did ls minus LART, Why it was not visible? Has it created somewhere? Has it created inside deploy? ls minus lart. No, where it has created and why this file is here. And if this file is here, then when I'm doing ls minus lart, why it is not showing? Anyway, let's go and edit that file. So nano dot env. I wanted a blank file. Why that? This kind of file I want, a blank file basically. Okay, that file is, let's say that file is not there. So I will copy this. That's just the template I'm copying. Okay, and I'll put here. And then what you can do is, if you want to save this, right? You can do a control X and control O. Sorry, control X. Yes, control O. Sorry, I'm forgetting the shortcut for nano editor. Cat dot env. Okay, so now what I'm going to do is I'm going to stop screen share and put my keys here, and I will not show you that. Okay, so don't mind guys, please. And this is how you have to update your keys. So let me stop sharing for some time. And I'm putting the keys. If you are doing with me, you can also put the keys. Okay, basically I need to go one step back, because in the project root directory we should put, okay, nano dot env. And here I'll put my keys. It will take 1 minute guys. I'm just copying my keys from my actual file where I put all my keys. I hide all my keys basically. So OpenAI key. OpenAI key. Okay, LLM provider, fine. Then I will put VV8 URL, https:// and that thing you should put https:// and then your URL. That instruction is there uh, in our instruction sheet. Don't worry. All instructions are there in our instruction sheet. Okay. And then what I'm going to do is I'm going to put my VB8 API key. Cat VB8 key, VB8 API, OpenAI key. Okay, I think I'm happy with this. So what I will do is I will start resharing my screen with you. Just a moment. Okay, so I'm sharing my screen again with you. What I have done is I have put my key inside this .env. Okay, and let me change also the permission of that. Sometimes the permission creates problem. But one thing is I'm little surprised how .env got created, and first time I did ls minus lart it was not showing. Anyway, I have the .env now and I can play around with this. So if you go to the instructions again, this is our deployment page, right? If you go to deployment page again, what we have done, we have copied the files, we have done our virtual environment is also created, but what we can do is run the script setup we have run. Create.in file template, you will edit this. We have already edited now, so don't worry. Now we will check if our requirements are working fine. So for example, our setup is working fine. So Python 3, Python 3.12.3. So this looks fine. We can go here. I mean, we are already here, but just we can go here. Python 3M virtual environment. Basically, one virtual environment is created for us. Okay, I want to use this only. So no need of creating a new virtual environment. We can simply activate the existing virtual environment, which is created as part of setup. Okay, created that we are inside that virtual environment now. And now if my key and everything is works fine, see it says configure environment variable. This I just did now. Okay, so that's fine. So this is how if you are using a nano editor, right? You remember I was struggling using nano. So if you want to save something in nano, you can do control X, then Y, and then enter. Okay. First control X, then Y, and then enter. So you want to see something, I will show you. For example, ls minus lart. And I can create a new file here, nano aman.txt, txt, just to show you. Hi, this is a nano edited file. Okay, so control X, then Y, then enter. Okay, and then I can view the content of that file. So cat aman.txt. Hi, this is a nano edited file. Okay, I don't need this file, so I'll simply delete it. So rm aman.txt. I don't need this file. Okay, so clear ls minus lart. All files are here. And we are ready to build our index. So you remember I was explaining you here, we need to first build our index. So we will call this script build index.py. So let's keep our fingers crossed, guys. This is using a lot of things actually. So it should run perfectly, otherwise it will create a problem. So how to build index? Python 3 scripts build index.py, that's it. Okay, so I'm running this and let's see if it runs fine or it gives any problem. Okay, looks like it is running fine. Downloading readme. If you see collecting paper chunk is there in my webit, so it is saying it's there. But again, it is creating from I have taken just 5 papers because this is a demo, right? So I have taken 5. You can obviously in config, right? So I will just stop sharing for one moment, guys. The reason being, am I not sharing my screen? You guys are not telling also. Am I sharing or not sharing? Yes, I'm sharing, right? I will do a stop share just for a moment. I want to do something. Okay, I will reshare. So I hope you are able to see my screen, guys. I will reshare my screen. Okay, and here we have pushed all our index here. I mean, we have done the index building. So I have put here. This is the kind of output you will see when you build your index there. Or if you have some problems, these are the kind of which I have faced when I build it first time. If you remember, right, in my AWS, I have built 3 different instances. The reason being, once I build, I faced some issues. Then I faced some issues, and now I'm showing you live. I did not want to share. Um, I mean, I did not want to confuse you with troubleshooting that I faced. So I have put the troubleshooting things here. Okay. And now what we can do is this is already activated. So we can launch our Streamlit app. Okay. So go here and launch the app with this command Streamlit run. Server address this server port 8501. If you see it says you can view your Streamlit app in your browser 00008501. The meaning is now this is an open internet thing, which means you can also watch this. So I will go here. I will take my IP address. This is my IP address. Okay. And let's go to open internet and let's say 8501. So this now you will be also able to access this app. Can you try to access this, guys? Go to your computer and just type this 54 colon 237, sorry, 54 dot 237.58.101 and colon 8501. Can you tell me if you are able to access? And then what I'll do is I will ask a query to this. Okay. So what I'm going to do is I'm going to ask a query, and query should be from the VB8. If you remember, this is the data we have pushed in VB8, right? So we discussed about this in part 1 and part 2 in detail. So let's go to any of the chunk and ask. Generalized form factors of nucleon. Okay, this looks little technical. So what is important about generalized form factor of nucleon? So can you try this, guys, from your machine if you are able to access my rack? And this is the answer coming. Okay, from the chunk 5. So there are chunks here and answer is coming here. And if you see on the left hand side, I have disabled re-ranking and disabled evaluation. So let me enable evaluation for one moment and let me search one more time. Okay, so we discussed in detail what is the meaning of precision, recall, MMR, NDCG, all these things we discussed in previous lecture. Re-ranking is disabled. Let me enable re-ranking as well and run. Can you tell me if you are able to access my application from local internet, basically your local machine open internet? So this will take some time because it is loading a model. So if you go to my this one, right, you will see that a re-ranker model is getting loaded. So it will take some time and then it will show you the result. So for the first time, it is loading a model. So re-ranking will take some time. So if I have to revise what we have done today, we have basically build the index using build indexing. This is as I like to call it, this is your prep part of RAG, or in other way you can say training part, but I like to call it prep part when you are preparing your knowledge. Okay. And then when we launched our Streamlit application, many things are happening inside app. So first thing is happening, that is matching. Then we are basically doing re-ranking. Then we are doing evaluation. Then we are showing the final answer, re-ranking. Then we are passing the context to LLM. Then we are doing evaluation, etc. So this is the flow that when we launch our Streamlit app, right, it goes through that channel. Okay. So if you are able to access, guys, then you can any of these queries you can ask something different than me. For example, if you are able to access my RAG, right, you can simply say I'll give you one query. Ask forward limit of generalized magnetic form factor. Ask about this. I will put in YouTube chat. Ask about this to the RAG in open internet. Okay. And then here again, through this, you'll be able to launch the app. Your app should be available at 8501 port. Okay. And you can access the application by Control C. You can stop the application. And for performance optimization, you can choose a different OpenAI. We have used a OpenAI embedding so that no model downloads needed. Re-ranking is disabled by default if you noted. Okay. Re-ranking may take 30 to 60 seconds. I'm not sure why connection is diffusing, but let's try again. Okay. So troubleshooting, if you don't get maybe a firewall issue, maybe you did not set the port right. So go back to my video and see how I have set the port. Your environment file may not have the right key. Your virtual environment may not be set properly. Some of the packages might be missing or Streamlit might be missing. You can do the apt-get update as a security best practices. So what we have done, we have used uh, things that will make your app faster or load faster. Okay, I think when we are doing re-ranking, the app is becoming slow. Re-ranker model loaded successfully killed. Okay, let's not use re-ranking for now. I'll relaunch the app. Okay, I'll relaunch the app. Without re-ranking, we can access the app. Okay, maybe in re-ranking there is something which is making the app go crazy. So we will just do enable evaluation, and we will put our query and we will search. Re-ranking is making the system slow, and I think the 20 GB of RAM is not able to properly handle it. Let me see how much space is free in my machine. Okay, I can see that afterwards, not a problem. So answer is here, evaluation metric is here. So up to evaluation, it's fine. But when I do re-ranking, there is something happens here and it gets killed. Anyway, so what we have done, guys, if you are doing with me, congratulations, your app is live on internet and deployed in AWS EC2. Okay, for questions and issue, check the logs or review the guide. All the instructions are here. You can try everything. I will give you this link one more time. Go to that, take the project, build it, and let me know how did you build it. This is where your all instructions are. Very simple requirements, nothing fancy. This is your environment where you need to put values. In deploy, you have scripts. One is for copying, one is for setting up. And the start app is basically either you can start using Streamlit command, or if you want to start using shell, you can do like this as well. Okay, if you are a shell script person, if you like shell scripting, you can do like this as well. And other things are basically we have discussed in detail in our previous models, previous lectures. Basically, what are these? Any queries, guys? I tried to keep it very, very simple so that you can easily understand and you can easily try anything that you want to ask me right now. I'm happy to answer your queries after the session also. And let me stop my two instances. Otherwise, I'll just terminate or delete instance. This was just for my practice before this session. Okay. So I will delete these two instances. This one terminated. And after your research, you can also delete your instance. You will end up paying some money otherwise. Okay.
Mm, I will simply delete because I have anyway one instance Aman AI running. So this instance, first two instances I'm deleting knowingly. If you go to this one, this is our main one. And I can click here also and open it. I can take some other query and ask. I will ask importance of quark orbital angular momentum. Again, this is optimized for uh, taking less time, but feel free to go to config and change the things, guys. Okay. So what I'm telling you is you can go to app, you can go to config.py and change how many papers you are reading. For example, now I'm reading 5 papers only. You can make it 50 also or 100 also, your choice. Okay. I don't want my build index to run very long, so I make it 5, but you can make it 50 or 100 also, not a problem. Make it chunking strategies we discussed in detail, overlap we discussed in detail. Just try with different fixed size, sentence based, semantic. Okay, in config, you can do all these things. So with a combination of shell scripts plus Python, we have built a very clean deployment script here, which you can take and use. Okay, I hope you like the session, guys. Give me a thumbs up if you like the session, and I'll keep meeting you through other YouTube videos, of course. And I read all the comments, guys. Please keep giving me comments on my YouTube videos so that I know you are watching, what kind of content you like, what kind of videos you like, right? I will know that if you keep giving me comments. Okay. With that in mind, you can download the code from here, try it out, and let me know how it went. And I will see you all in my next YouTube. Fine. Thanks everybody for joining.